Hi, my name is Rutuj. Our topic for project implementation is human activity recognition. My group members are Ritika, Sinha, and Kumar, Anubhav. So before going in depth of implementation part, I would like to give an overview of what we are doing. We know that smartphones have become most useful tool in our daily life for communication with advanced technology, provided intelligent assistance to the user in their everyday activities. Mobile phones have highlights such as cameras, GPS, web browsers, and so on, and implanted sensors such as accelerometer and gyroscope, which permit the improvement of applications in view of client's specific area, movement, and context. There is something called as activity recognition, which is monitoring the liveliness of a person by using smartphone. Smartphones are used in a wider manner, and it becomes one of the ways to identify the human's environmental changes by using the sensors in smart mobiles. Smartphones are equipped in detecting sensors like gyroscope and accelerometer. The contraption is demonstrated to examine the state of an individual. Human activity recognition framework collects the raw data from sensors and observes the human movement using different deep learning approaches. Deep learning models are proposed to identify motions of humans with plausible high accuracy by using the sense data. Next, the question is how the data was recorded. The 30 participants, which are referred to as subjects in this dataset, performed activities of a daily living while carrying a waist-mounted smartphone. The phone was configured to record two implanted sensors, which are accelerometer and gyroscope. For this time series, the directors of underlying study performed feature generation and generated the dataset by moving a fixed width window of 2.5 seconds over the series. Since the window had 50% overlap, the resulting points are equally spaced. This experiment was video recorded to label the data manually. By using the sensors in a smartphone, they have captured the 3-axial linear acceleration from accelerometer and 3-axial angular velocity from gyroscope with several variations. Now, I will give the quick overview of dataset. The accelerometer and the gyroscope readings are taken from 30 volunteers while performing the following 6 activities. These activities were walking upstairs, walking downstairs, standing, sitting, and lying. Accelerometer readings are divided into gravity acceleration and body acceleration reading, which has X, Y, and Z components each. Gyroscope readings are the measure of angular velocities, which has X, Y, and Z components. Jerk signals are calculated for body acceleration readings. Fourier transforms are made on the above time readings to obtain the frequency reading. We get a feature vector of 561 features, and these features are given in the dataset. Each window of reading is a data point of 561 features. This project is to build a model that predicts the human activities such as walking, walking upstairs, walking downstairs, sitting, standing, and laying. The problem statement is given a new data point, we have to predict the human activity. Now the question is, which type of ML problem is this? So human activity recognition is a challenging time series classification task. It involves predicting the movement of a person based on census data and traditionally involves deep domain expertise and methods from signal processing to correctly engineer features from the raw data in order to fit a machine learning model. Or in other words, you can tell it is a multi-class classification problem. For given new data point, we have to predict the human activity. And each data point corresponds to one of the 6 activities in this case. So now we will see the implementation part. We started with loading the feature.txt file, then train the data and test the data and the analysis of this data. Next, we did some data cleaning like checking duplicates, checking null values, and save this data frame in a CSV file. Here, first we perform the EDA, which is exploratory data analysis on expert generated dataset. We try to understand the data, then create some machine learning model on top of it. First, we will see the participants' activity duration. Here you can see nearly all participants have more data for walking upstairs than downstairs. Assuming an equal number of up and down walks, the participant needs longer walking upstairs. We know that we have 6 class classification. So we have the big problem is to know how to or check is there any imbalance in the data. And after plotting the above graph, we can say the data is balanced. We have got almost same number of readings from all subjects. The next question is, how many data points do I have per class. So data is almost balanced, although there are fluctuations in the label counts. The labels are quite equally distributed. Assuming the participants had to walk the same number of stairs upward as well as downward, and knowing the smartphones had a constant sampling rate, there should be some amount of data points for walking upstairs and downstairs. So disregarding the possibility of flawed data, the participants seem to walk roughly 10% faster downwards. Next is feature engineering from the domain knowledge. So now the time is to know the static and the dynamic activities of human. In static activities like sitting, standing, and lying down, motion information will not be very useful. In the dynamic activities, which includes walking, walking upstairs, walking downstairs, motion info will be significant. Here we are using T-body ACC MA Gmin, which is T-body acceleration magnitude feature mean value function, to plot the graph for better understanding of static and dynamic activities of human. We can see the T-body ACC mag mean feature, which separate very well the static and the dynamic activities of the human. Now we plot the static and the dynamic activities of human on box plot for understanding. So here you can see if T mean is less than minus 0.8, then the activities are either standing or sitting or laying. If T ACC mean is greater than minus 0.6, then the activities are either walking or walking downstairs or walking upstairs. If T ACC mean is greater than 0.0, then the activity is walking downstairs. We can classify 75% the activity labels with some errors. Next, we'll see the position of gravity. Position of gravity acceleration component also matters. So if angle x and gravity mean is greater than 0, then the activity is laying. We can classify all data points belonging to laying activity with just single if-else statement. So now next we applied the TSNE on the data. So applying the TSNE on the data to know how much activities are separable. So we know that we have 561 dimensions, expert engineered feature. Now apply TSNE on these features to see how much these features are helpful. So here we can clearly see that the TSNE cluster, all the activity are clean, separate except standing and sitting.
Hi, my name is Kumar Anubhav and my roll number is 2111 MC15 and I am from MTech Mathematics and Computing. So Rutuj has already explained about the topic and the data set. In continuation of that, I'll be explaining about the machine learning model that we have used in our project. So in the first step, we have imported all our required library for this project, including NumPy, Panda, itertools, sklearn, matplotlib, and all ML models that we have used here. Then we have loaded our data set. The first one is train.csv, that is training data set, and the second one is test.csv, that is testing data set. We can see here that the training data set containing 7352 rows and 564 columns, while the test data set containing 2947 rows and 564 columns. Now, these are the features that is present in our data set. So for every model, we are looking for some important features that we are doing here, the feature extraction, we can say. So the features like subject, activity, and activity names are not so important while training our model. So we are dropping it. So after the deletion of the not important features, the training data set containing 7352 rows and 561 columns, because 3 columns has been deleted. And similarly, in the testing data set, we can say that it will consist of 2947 rows and 561 columns. Now, these are the class levels, or we can say that these are the human activities that we are looking for. The first one is laying, then sitting, standing, walking, walking downstairs, and walking upstairs. Now, this is the function to plot the confusion matrix. So confusion matrix is very important in terms of precision recall. We can say that for every model, we will calculating the precision and recall for each of the classification level, and in similar fashion, we will calculate the confusion matrix for each of the model. Now the second one is the generic function for all of the model. So it will calculate the training time here. Now the testing time, similarly accuracy for each of the model, and finally the confusion matrix for every model. Now this is the function to print the grid search parameters. So grid search is a process that searches exhaustively through a manually specified subset of the hyperparameter space of the target algorithm. The question may arise here that why we are using it. So grid search refers to a technique used to identify the optimal hyperparameters for a model. Unlike parameters, finding hyperparameters in training data is unattainable. As such, to find the right hyperparameters, we create a model for each combination of the hyperparameters. So we have used here 561 expert engineered features, and we will apply classical machine learning model on top of it. So in the topic, it was asked to implement for at least 3 models. So we have tried to implement for the logistic regression with grid search. In the second, we can say we have implemented for linear support vector classifier with grid search. And our third model is kernel SVM with grid search. The fourth one is decision tree with grid search CV. And the last one is random forest classifier with grid search. So I'll be explaining one by one in brief. So the first one is logistic regression. So logistic regression is a linear model for classification. In this model, the probability describing the possible outcomes of a single trial are modeled using a logistic function. The logistic function is a sigmoid function which takes any real input and outputs a value between 0 and 1, and hence it is ideal for classification. So when a model learns the training data too closely, it falls to fit new data or predict unseen observation reliably. The condition is called overfitting and is encountered in one of the ways. So we have studied in our class also that using regularization, or we can say it is also known as ridge regularization, it penalizes the model predictors if they are too big, thus enforcing them to be small. This reduces model variance and avoids overfitting. We can also do hyperparameter tuning, or cross validation is a good technique to tune model parameters like regularization factor and the tolerance of stopping criteria. Here a validation set is held out from the training data for each run, while the model is trained on the remaining training data and then evaluated on the validation set. This is repeated for the total numbers of folds, and parameters from the fold with the best evaluation scores are used as the optimum parameters for the model. Now we can see here that this model takes around 11.94 seconds for training time and around 0.01 second for testing. And the accuracy for this model is around 95.82%. And this is the confusion matrix. We can also see here the confusion matrix here for the laying classification level. It is around 1% of the precision. So, and for sitting, it is around 0.88 and standing 0.97. For similarly, we can see here for all the human activities. Now the second one is linear support vector classifier with grid search. The objective of linear support vector classifier is to fit the data we provide, returning a best fit hyperplane that divides or categorize our data. From there, after getting the hyperplane, we can then feed some features to our classifier to see what the predicted class is. For this model, we can also see that the training time is around 32.04 seconds and the testing time is around 0.08 seconds, while the accuracy of this model is around 96.7%. In similar fashion, we have created the confusion matrix as well. Now we can see the precision for each of the positions, or we can say for each of the activities like laying, sitting, standing, walking, and walking downstairs and walking upstairs. Now the third one is kernel support vector machine with the grid search. So support vector machines use a set of mathematical functions that are defined as the kernel. The function of kernel is to take data as the input and transform it into the required forms. Different support vector machines algorithms use different types of kernel functions. These functions can be of different types. So for this model, it is taking around 3 seconds, 3.45 seconds for training and around 0.1 seconds for testing time. And the accuracy for this model is around 96.27%. Similarly, we have created the confusion matrix for this also. Now the next one is decision tree. So decision tree is hierarchical model, also known as classification and regression trees. So they have the property of predicting response from the data. The attributes of the decision tree are mapped into nodes. The edge of the tree represents the possible output values. Each branch of the tree represents a classification rule. So we can say that from the root to leaf node, each of the branch here representing some types of classification rule. So this method has been used for several tasks in the fields of pattern recognition and the machine learning as a predictive model. The main goal is to predict the next given value for the several input variable. So in this model, it is taking around 10.95 seconds for training and around 0.008 seconds for testing. And here accuracy is low as compared to the previous model. It is around 86.42%. Similarly, we have created the confusion matrix here for each of the classification levels, and we have calculated the precision and recall. Now the last one is the random forest classifier. So random forest is an output of unprone demand or descents like bootstrapping algorithm with various decision trees. So each tree depends upon the estimations of the vector picked unpredictably and independently. Random forest reliably gives an immense improvement than the single tree classifier, each tree fabricated using the algorithm. So we already know the concept of the random forest. Like here, several decision tree is made, and with each of the combination of the features, and from that we select the best one. So model name features hyperparameter training accuracy. We can see here in the last things we have compared all our models, and for the previous one we can see that its training time is around 9.21 seconds, and the testing time is around 0.05 seconds, while the accuracy is 92.97%. So while comparing all our models, we can see here that the logistic regression is giving the accuracy of 95.83, and it's giving error of 4.17%. Similarly, linear support vector classifier is giving accuracy of 96.71%, while error of 3.291%. Similarly, RVF support vector machine classifier is around giving accuracy around 96.27% and error of 3.73%. Now decision tree is giving less accuracy than other. It's around 86.43% and an error of 13.57%. And the random forest is giving accuracy of 92.98% and an error of 7.024%. So we can clearly choose here linear support vector classifier or RBF support vector machine as our model because it's giving best accuracy on our data sets. And we are testing the data. So on the testing data sets, this is the accuracy for each of the model. So from here, we can conclude that linear support vector classifier and RBF support vector machines are best and suitable for our data sets. And for that, we can say that this is the best model we can use here because it's giving good accuracy. Thank you.
Hi, I am Ritika, Sinha, roll number 2111 MC09, first year MTech Mathematics and Computing. In Continuation to the machine learning models explained by Anubhav, I will be elaborating how we created the LSTM-based deep learning model on top of raw time series data. Human activity recognition is one of the time series classification problem. In this project, various machine learning and deep learning models have been worked out to get the best final result. In the same sequence, we can use LSTM model of the recurrent neural network to recognize various activities of humans like standing, climbing upstairs and downstairs, etc. This is our Python notebook for implementation of LSTM. First, we import the required libraries. Then we create a list containing the 6 class labels for classification tasks. Next, we create a function to visualize the confusion matrix. Gives us a holistic view of how the data we are predicting. Now, we move on to the process of loading data. We created a list for recording the signals. Then functions are defined for reading CSV file and loading signals. This function returns the number corresponding to the activity in one-hot encoding, which it represents using zeros and ones. This one is used for loading, training, and testing data sets. Here we have taken the number of epochs as 30, batch size as 16, number of hidden neural layers as 32. Function is defined for counting the number of classes. Data is loaded and we print the number of time steps, input dimensions, and training data set. Now let us understand what is LSTM. LSTM model is a type of recurrent neural network capable of learning order dependence in sequence prediction problems. This model is used as this helps in remembering values over arbitrary intervals. The unit is called a long short-term memory block because the program is using a structure founded on short-term memory processes to create longer-term memory. In general, LSTM is an accepted and common concept in pioneering recurrent neural networks. Now that we have understood what LSTM is, we define the architecture of one-layer LSTM. For this, we have initialized the sequential model. Then the model is configured by creating an LSTM with a predefined number of hidden layers. A dropout and a sigmoid layer are also added. This is the model summary. Now the model is compiled using categorical cross-entropy loss function, RMS crop optimizer, to reduce vertical oscillations. The model is trained and we obtain an accuracy of 94.76% after 30 epochs. The confusion matrix is used to get a visualization of how our model is performing on the test data set. We get 0.47 as the categorical cross entropy and 90.09% as the accuracy. Now we will define the architecture of two-layer LSTM with more hyperparameter tuning. The first model, we initialize number of epochs as 30, number of batches as 60, and the number of classes. For bias regularizer, we use values 0.1, 0.01, and 0.01. Now for execution, we create a sequential model, then add LSTM, dash normalization, dropout, LSTM, dropout, and sigmoid function. Then a summary is generated. The model is compiled using categorical cross entropy function and Adam optimizer. Here we get 0.39 as the categorical cross entropy and 94% as the accuracy. Similarly, another model is generated and 0.27 is the categorical cross entropy and 91.72% is obtained as the accuracy. Now we come to the conclusion. We see that linear SVC or RBF SVM classifier or logistic regression can be chosen as our best model while applying ML classical model, as they are having accuracy scores greater than 95% each. Now let's look at the comparison of deep learning models. When we are talking about LSTM models, here with LSTM we are using simple raw data. In ML model we are using single engineered data made by an expert, but we can see the result without any FE data. LSTM performs very well and got highest 91% accuracy with two-layer LSTM with hyperparameter tuning. And also when we are increasing LSTM layer and hyperparameter tuning, the cross entropy value is decreasing and the accuracy is increasing. Thank you for listening to our presentation and have a good day.